All right, welcome to another coding session. Getting stuck back into it. I've got a few ideas actually of the next things I want to do in the language. There's some things, some quality of life things in the compiler, in the code of the compiler, just to make it, I think, a bit easier to work with that I want to do. But last episode we did, stuff kind of like that. Last episode we were restructuring things a bit. So this episode, let's implement a new feature. And the feature I was thinking to implement was scopes. I feel like scopes is the gateway drug to other things, to flow control. If statements, loops, functions, they all need to have a scope, right? And I was trying to think, what is the scope? And maybe it will change later, but I mean, right now with our basic program, I guess the scope is just a place to hold variables, right? Like at the start of a scope, we would say, okay, this is the current stack position. Our stack is filled up to here. Actually, I keep forgetting to, I need to remember this. I keep forgetting to use my drawing program, to visualize stuff. So we have a stack, we're growing our stack and it's got some variable in it. And then we push something else onto the stack, and then we push something else onto the stack. And then here, we're going to enter our new scope, right? Let me move this over here. I am, by the way, adding this, it's called Excalidraw is the program I use. I'm adding the canvas here to the description of the videos. So if you did want to have a look around in here, you can. And don't worry, it won't modify my version. It's like it kind of makes a copy of it, you could say. Anyway, so we're building up our stack, some variables on the stack. We have our stack pointer here, and then we enter a scope. And then that's what when I was thinking, we'd have like we'd keep track of this as our scope start. And then within our scope, we push a few more variables onto the stack. So our stack pointer goes up here now. Every time we push something onto the stack, then the pointer moves up. Now, that reminds me, I'm pretty sure, I have to check this from my other program, I'm pretty sure there are commands for push and pop. And I've been doing this manual business to move things onto the stack and then advance the pointer, where I think there's just like a push operation which would just do it. Oh well, it doesn't really matter. So I got sidetracked there, sorry. So we've entered our scope, we added a couple more variables, and then when we exit our scope, we want to say, okay, just discard all this and go back to the start of the scope. And that's the meaning of the scope, basically. It's a place to hold additional variables in the stack that are conveniently deleted once we leave the scope. That's pretty much it. There's kind of two main ways I can think of that you would have a scope. The way that we would have it at the moment is like if we have x equals 42, and then we could enter a scope and say y equals 7. And what I was going to say is we don't want to be able to, well, if we go x equals 9, what would you expect to happen here? I think a lot of programmers would expect that this variable here changes to 9. but I think this is ambiguous. I think this is ambiguous because my declaration of a variable is the same as assignment. And I was saying that I didn't want to allow shadowing. Yeah, this is where it gets confusing. So I didn't want to allow shadowing. So you can't declare a new variable with the same name within a scope here. You couldn't declare X. You can only assign to X. But because the syntax of declaring and assigning is exactly the same, it's really not clear which one you're doing. So I think I'm just going to steal the Odin syntax. I think we're going to change our syntax a little bit so that you have to go like that. And then for the Y, you're also declaring Y is 7. Then you're allowed to do this. This is fine. But this is a no-no because that's shadowing. Now you have two variables called X, and within the scope, you're using this one, and then when you leave the scope, you're using this one. It's just, I don't like it. It's a bit confusing, so we're not going to support that. So that should be an error. And that's why we're going to have the two syntaxes so that it's nice and clear. You can do this. You can update X. And then once you leave here, Y is a no-no. Whoops. That's not what I wanted to do. Pencil, no. Got a pencil here. Okay, pencil, red, and now I've gotten rid of my text. Anyway, I just wanted to cross it out. You can't do that because Y doesn't exist outside the scope. Now, the other way that this works, the other kind of scope that I thought of is that if you then call a function foo, and the foo is like this, right? Let's move our stack stuff out of the way. Oh my God. So foo is like this. And within foo, of course, you can go foo equals 7. Not foo, X. Let me update that. Because this, within foo, we can't see this X. Well, let's make it even more clear, right? We declare foo up here. So when we call foo, foo doesn't know about X, but it can declare an X. It's kind of like its own self-contained area. It's not like this here, which is not. Let's, I want to make this quite a bit more clear. So these are two different functions, right? So it's fine that we have X here and here. And actually we could call one from the other. And so when you call bar from foo, the reason what I'm trying to get at here is when you call bar from inside foo, you're starting a new scope, right? But in this new scope, you can declare an X, even though a X is declared in the outer scope. So there is an X on the stack. Now you're putting another X on the stack. That's possible here. But with this kind of scope, that's not possible. So that's the two kind of situations I thought of. Anyway, this will inform the way we code this. So we're going to go to our grammar here. We're going to add an extra line, and we're going to say that a scope is very similar to a program. It's like, it's just got curly brackets, right? Do I have to? So that's square brackets. maybe I have to do like this, and do I have to like escape that? Yeah. Do I need to, can I just do that? I can just do that. Let's just do that, hey? Yeah. So it's the same as a program, right? It's just a list of statements, but it's inside some curly braces. And when we get to functions later, we go back to our diagram. See the function, it still has, so that's the scope part of the function. And this is kind of the signature of the function, and this, the body is like the scope, which is the curly braces and the statements, just like the scope. So curly brace and statements in a scope, that's what we want to implement. So let's go through the stages. Well, let's at first, to test this, I guess the first thing that I said I wanted to do was change the syntax so that we're like this. So to do this, I think first thing first is always the tokens. We've got an equals token. I think we're just going to make a colon token. Yeah, I think that's what we'll do. And it's just another single character token. So the tokenizer part is dead simple. Done. We can now accept colons as tokens. When we are parsing, well, when we're parsing, we have two kinds of statements now. We have a, what would you call the first one? Declaration statement and an assignment statement. Let's just call it for that for now. I don't know if that's the best naming. Maybe later on we'll figure out. So we have a new type of statement. It also starts with an, well, I mean, it's covered in here already, almost. When we do the assignment statement. So yeah, if that one is an equals, then what we kind of want to do is we want to have even another nested switch in here for +2. And we'll just, I think for all of these, we need 2 more tokens. We always need 2 more. At least, so that I think that's safe just to put that check there. So, oh, actually this is equals, no, I don't know if we do need to do another nested because it's if we have a colon next. If the second token is a colon, then we're talking about a, what did I call it again? Declaration. Declaration statement. Prop that up a bit. So we have a declaration node and a declaration token count. Okay, and we need to parse the declaration statement. So it's going to look pretty close to parsing the assignment, I would say. Declaration, we're going to verify that we have 3 more tokens for a total of 4 tokens in the statement, because we need, here's a declaration. I think it might be easier just to go to our source code here. Here's a declaration. So we have 4 tokens, x colon equals 57. And I've just chosen to put the spaces here, like white space means nothing, you know, it could be like this, could be like this, whatever. You could put a new line and you could go like this. That looks a bit weird, but currently that would work. Anyway, so we go back to our parsing. So for this statement, we need 4 tokens. So that's the start plus the other 3. We're saying it's a declaration statement. The LHS node is the identifier of the first token. Very good. This is our colon. This is our equals. We don't verify that it's an equals. I guess for the other statement, we've already verified the equals here, so we don't need to. I'm curious for the exit statement. We do. We reassert the opening bracket, even though it's already been verified here that we do have an opening bracket. I think for completeness of the exit statement, that's nice to just verify all of the tokens, even though we're not actually verifying the first one. So we have our declaration statement. Our first token is our identifier. Great. Then we have a colon, then it equals. And I think I'm just going to verify that those both are what we expect. So there should be a colon and an equals, and they're the second and third tokens. This is what, this kind of stuff is what I really want to fix up in the next session, because at the moment it's a bit confusing. If you're being confused by this, it's because I'm doing a shitty job of coding it, not because it's confusing. But we have the identifier on the left, the colon and the equals we're advancing past and just making sure that that's what they are. And then we get to the right-hand side, which is exactly what we would want to do, I think. Down here for the assignment, the assignment is what we had before. I'm just going to add this, though. It's just like an extra little double check, which is probably not necessary, but it's the equals. Just verifying that the equals is an equals. There, I think that's it. So we can parse that statement now, and then in generation, when we're generating a statement, we can generate a declaration statement. And we'll duplicate this guy. And let's see. Declare. So the left-hand side node, the right-hand side node. We still just have 2 nodes coming out of there for declaration. Yeah, we have the left-hand side node and the right-hand side node. So that's correct. The left-hand side, no, the right-hand side it's checking, yeah. So if the right-hand side is an identifier, then we're moving that variable into racks. If it's integer literal, we're moving the integer literal into racks. And then, so this if else is basically saying, is it declaration or is it assignment? Well, I guess I'm saying declaration, it's kind of like declaration and assignment that I'm talking about, you know, x colon equals y. It's like declaring x and assigning it the value of y to it. So it's both. And if it already exists, then we're not declaring, are we? This is the assignment case. And if it doesn't exist, then we are creating it. This is us creating it. And this is where I think there is actually a push operation which would be better than this. But I'm not going to worry about that right now. We're not worrying about having efficient assembly, just assembly that's clear enough and works. That's the goal at the moment. As long as the assembly is not sort of like really confusing and hard to understand, then we're good. So now we're going to say if it does exist, if this variable already exists, that's an error. So we'll say like, do we call it variable, our identifier? Identifier already exists or something. And then if it passes that check, then we go ahead and create our new variable and assign, we assign our value to the variable and create it. Great. So that is declaration. I've just noticed in here we're saying undeclared identifier. Yeah, because no, that's bad. No, yeah, the one on the right-hand side. The right-hand side identifier does need to exist. Okay, and now we go to assignment. This is what we're assigning. Yeah, this whole thing here is still correct. That's what's getting assigned to it. We're more interested in this down here. So now it's like this is the assignment case. This is what we want to actually do. And up here, I think we want to invert this and say, if the variable does not exist, now that's an error. That's undeclared identifier. Undeclared identifier. I think that should work. Unrecognized token. Oh, really? The colon is the only new token. Oh no, I've got the scope in there already. We haven't handled scopes yet. Invalid term. Okay, it might be because we're not looking at the fourth when we do our assignment, when we parse our assignment. So parsing assignment should be correct because we're taking the third token. I guess actually to be safe, it would be like plus token count. So token count starts at 0. Everything in Odin starts at 0. 1, 2, so now it's 2, which is correct for assignment. And here, we're saying goes to 1, 2, 3. So I think what was happening was the code that tries to parse the term was looking at this equals, not looking at this. Let's try that again. Okay. We're printing out our AST tree still, it seems like. Let's have a look at our output. Okay. We're declaring a variable with the value 57. Great. We're declaring another variable, which is taking the value from the previous variable. Now we're assigning to an existing variable the number 34. and we're exiting. And that looks totally right. That looks totally right. If I try to do an x equals 57, I should get undeclared identifier. Undeclared identifier. Was it in generation? Yeah, generation undeclared identifier. And if I try to declare y twice, it should say identifier already exists. Yes. So we go like this, and we should get, we should get our exit code of 34. So let's verify that. Beautiful. Okay. I think I might commit that. That seems like a self-contained thing. So that's separate syntax for declare versus assign. That's not how you spell separate. Separate. Cool. That commit included that change, which is not to do with that, but whatever. So now let's do our scope. So in our example, let's do z equals 10, and then z, we'll declare z again. We'll say z equals y, and exit z, why not? So yeah, z should get created in here, destroyed at the end of the scope, created again, and then used. All right. And how do we do this? Well, in our tokenizer, we have a couple of new squigglies. Opening and closing squiggly bracket. Let's put them in here. Opening squiggly bracket, closing squiggly bracket. Okay, so we have the new tokens ready. Now in our parser, remember our parser is doing the recursive descent parsing, which then treats all of these as a function. And I didn't mention this before, but the reason it has recursive in it is because like this scope could have some statements in it. It could also have a scope within it. That's interesting. We're not handling that right now according to this grammar, but you could have you could keep nesting scopes, right? Yeah, I guess we won't handle that for now. But the point that I was trying to make was that if you had a scope within a scope within a scope, then you would kind of be recursing through these functions, right? Scope would call some statements, and then there would be a scope in here, so then it would go back to here and call scope again, and you recurse. So that's the meaning behind that name. I don't know why descent passing. It doesn't really matter. So now for our parser, we want to have, I guess, a scope node. So, you know what, I just realized that our grammar is really not very proper, because in our program, we're not even saying anywhere that there could be a scope. So maybe a scope is a type of statement. Maybe a scope is a type of statement. Yeah. So maybe we'll move it below statement, and then one of the cases in here, I feel like it should go at the top. Scope is a big thing. And it goes in square brackets. I'm curious, why does he put this text thing? Oh, it stops it from being italic? What would you want to have italic and what would you not want to have italic? I want to learn this a bit better. So scope equals, oh no, we're just saying it could be a scope, right? A statement could be a scope. So we can be recursive. We are recursive now. So a program can have statements in it. One of those could be a scope, which then in turn has more statements in it. Great. We actually have a properly recursive parser. So now when we go into statement, when we're parsing a statement, the first thing in the statement could be an opening squiggly bracket. And if it is, we're going to parse a scope statement, which sounds wrong. It sounds really, what I mean by that is it just sounds strange, right? For a scope to be a type of statement, but it works for us. Let's see. Parse scope statement. So let's create the function, parse scope statement. And we'll set the node to be a scope. And then it has a loop of statements in it again, right? So again, we're going to be doing something like this. Until, as long as we don't find a closing bracket. This is not quite right, but it's kind of the gist of it. That we're going to, and it'll be node dot children. So the scope node is going to have all these statements as its children. But the first thing we need to do is, we don't do it anywhere else. We don't, and we'll do that when we clean up. I was thinking we need to verify that we have an opening bracket, but we don't need to do that. But here we need to check start at start index. If the token is P, or is it start index +1 is where we start? Yeah, because we don't, the first one is the opening bracket. We don't want to use that. So if token index dot type is a closing squiggly bracket, if I got that right, token, there we go. Then we're done. We are done. So that's where we return, actually. And if we get to the end of the file, we also return. But if we get to the end of the file without finding the closing squiggly, that's an error. That does not seem valid. Yeah, we're just going to give this ridiculously. Oh, okay, scope never ends. That's a little bit better. So what we need to figure out now is, are we keeping track of our indexes and stuff properly? So when we pass this statement, it used this much tokens, so we increment our index by that amount of tokens. And then when we come around, we start at the index for the next one. Yeah, I think that's right. I do think we're going to have to do this just to move past. No, because the squiggly bracket was not there. And I don't know if we need this separate index variable. I mean, the token count is really what we're interested in, right? So we say child token node and child node. And then we say, token count plus equals, and we say token count less than this. Remember in Odin, a while loop is everything uses the keyword for. So this is a while loop. And then it's like start index plus token count. So we are going to go token count plus equals 1, and that is the opening squiggly bracket. So we're just moving past that. And then as long as we've got more tokens to look at, then we say, hey, so actually it's start index plus token count. So if start index plus token count, we find a closing squiggly bracket, then we're done. We return. We've done all of our statements. But we also need to account for it, right? We need to say we sort of consumed it. Now down here, we're going to go like this. Because we incremented token count, this is still correct. So we're saying, oh, no, well, this is at the end. But because we incremented this one, we're at the right place. Parse a statement, append the statement to the node. The token count, we increment by how many we used, and then we try again. I think that's right. I think that's how we parse a scope. Now generation, I'm going to generate a scope. I like to keep things in kind of the same order. Well, it's a scope statement, isn't it? So we just have another thing like that. Have another, these, I think of them as kind of like routing functions. This one is nice and straightforward. This one is a little more involved. This one here, it's kind of ugly. But it's just it's just separating. I should probably call it a scope statement, since we're saying it's a type of statement. No, in our grammar we don't. It's like a different thing. Yeah, okay. Yeah, I think our terminology is a bit messed up, but let's go with it. So when we parse, we have a scope. We don't have a scope token, we have a scope node, right? So to generate a scope statement, just going to say generate scope. And parse scope. I feel better about that. Okay. Let's put a comment in here to say we're starting a scope. And so we need that scope start that we said before, and that is this current top of the stack. Then we need to generate the statements within the scope. So again, that's going to look kind of like this. Actually, something I realized is we can just go, because a lot of our loops we end up needing to manually track the index, which is why I haven't been, or manually update the index, which is why I haven't been using these kind of loops, but here we can. Nice convenient loop. Node dot children, and we call that child node. We pass in, so we just pass in the same stack. And the reason we pass in the same stack is because, like I was explaining here, we still want to be aware of these variables. We don't want to be able to do this, right? And so by passing in the same stack object, which is keeping track of those variables, it will do, it will say, look, this variable already exists, you can't use it. And this is where I was talking about earlier, how there's this kind of scope, which is another function, the function foo calls the function bar, and they both declare X, and that's fine. And when we get to that kind of scope, we're not going to do it today, but when we get to that kind of scope, we would probably create a new stack object to start tracking the variables within bar, so that there's no name conflicts between the variables and outer scopes, if that makes sense. Anyway, we don't need to worry about that yet. It's just kind of a thing that I thought of that I need to handle. But when we're generating a scope, we just keep track of the top of the stack, we generate them, and then we're just going to have like one line of assembly. And so the stack pointer is then going to need to have, we're going to need to just move that back into it, I think. Clear stack for scope. Or clear, it's the stack, the scopes stack. Good enough. I think that should work. I feel like normally it would be like, another way you could do it is to sort of like do would it be an add to move it back up? But then we need to know the difference. We need to calculate the difference between the top we recorded here and the top after. And I can't be bothered. Like, you can just do a straight move. Now, also, we need to go we need to say that the top of the stack is the scope start. you know what? I think we do need to make a copy of the stack because new variables are going to be entered into this into this stack object, which tracks the variables, when we're doing these statements, these generate statements. I'm pointing with my finger, but you can't see. When we do these, they might make new variables. And then when we leave, we need to get rid of those variables again. So maybe it's easiest if we just make a copy of this stack. If we go like scope stack equals stack. Now that's a pointer to a stack. So I think what we need to do is actually say, I think you put it here. So that should copy the stack, I believe. So that's saying what stack points to, we assign to this. Then we don't actually need to do this because this guy is going to have the top of the stack. You know, we just need to go like this. Now, because this stack top should not have changed because we're just going to take a copy and we're going to pass them in here. We need to use the address because we need a pointer. But yeah, so we make a copy of the stack and we pass it in. Yeah, okay. I think that's it. Make a copy of the stack, use that within the scope, and then at the end, we go back to where we were in the beginning. So we're not clearing out any memory of those extra variables that got added. That doesn't matter. We're just going to move the pointer back up so that it's ready to so that memory that was used within the scope can then be reused in other scopes. Okay. Kind of surprised that that's kind of it. I feel like scopes is a bigger thing. So let's see what happens when we try to compile this. No errors? What's our assembly look like? Huh. Oh no, because I needed to press this. This is the part. Okay, identify error exists. Yeah, well, we should get identify. No, we shouldn't get identify already exists. This was where it would be really nice if we got a line number to know. Yeah, so that's what it's complaining about. It's saying Z already exists, which it should not, which makes me think that this taking a copy of the stack thing is not working properly. So if we come to the end of the scope, we put a breakpoint, and then we examine our stacks. So the top is different. Oh, but it's probably done a shallow. Oh no, look, we have 3 things in here, 2 things in here. Length 2, length 3. I don't think I can really look at the data in here properly with the debugger. But then why would that be an issue? You know, when we step out of here and we step over, then we start a new statement, go into that, go into that, and it's a declaration. That makes sense. We're declaring Z in the, we should be on this line now. We're declaring Z. So we go over this, go to our left and right hand side, go here, this, that's fine. And then we say if this value is in the stack Z, then identifier already exists, and that's what happens. So I think, where are we? Generation? No. Parsing is where the issue is happening, I think. No, it's generation. It's the scope generation. This is where we do this stack business. So it is making a copy of the stack, but I think that the vars is not being copied, and I'm really not confident that that's going to do a copy, but the identifier already exists. Can we figure this out? Well, I am on the maps thing here. I don't think it's going to say how to copy a map, though. Odin copy map. Because I don't want to take ages trying to figure that out, I'm just going to do this the manual way. So yeah, so what I'm going to do is I'm going to say that we're just going to declare a stack. Oh, of course that doesn't work because that okay, I'm going to do that. We'll call it parent stack. If we're going to have to give it a more explicit name, then we do that. So now we're just going to create a whole new stack, and we're going to say stack.top, parent stack.top. That's probably not going to work still. So then we're going to have to go like for can we do that? So key, I don't know if that's actually correct. Huh, maybe that is correct. Oh, okay. So I'm just manually doing a copy basically. I'm just copying the top over and then just manually copying all the values from the map to the new map to make a copy, and then it seems to have finished fine. And here we can see that we have our declare assign, and then we enter a scope. Maybe I'll actually put a 2. I think I'd like to have 2 comments here, like scope start and scope end. I think that would be clearer. Okay, scope start, scope end. So we move 10 into racks, and then we put racks on the stack. and allocate space in the stack. And then we clear the scope stack, which puts it back to 16. 16 should be enough space for 2 variables. And we have 2 variables up here. And then after that, oh my God, where am I? And then after that, we declare a new variable and we exit using the value of that variable. And that variable also is assigned from another variable. Whew. We're using all of our language features for sure here. Not that there are many, but okay. Compile's fine, link's fine. But we get a segmentation fault. It might be this guy here. I think we do have to do a sub because this is probably totally not right. Yeah, because the stack is in memory, the stack is at the top. You know, it's kind of, maybe I can visualize this too. It's like if we have all of memory like this, then it's like we've kind of got 2 things going on. Oh, no, we'll just say that down here is the heap, and up here is the stack, and then so the stack goes down and the heap goes up. So addresses in the stack are going to be very high, you know? It's like we've got address 0 down here and address, I don't know, FFFFFF up here. So then when we come along and we say, I would like to put the stack pointer at address 16, please. That's totally wrong. Totally wrong. So let's correct it. So we are going to have to do the sub that I was talking about, or actually it's an add because we're moving up in the space, right? So we're going to need to say this top minus that top. It's the scope stack size. So that's the amount of scope space, the amount of stack space that our scope has taken up. So we're going to need to add that to the stack pointer. Then we get clear scope stack. And this is actually more readable. You know, we created one variable here. See, it's like sub add. So we allocated space on the stack, and then we clear sub add. I mean, that looks pretty legit. I think that's going to work. Confidence is high. 34. Is that what it should be? So y is 34. Z becomes y. Exit with Z. 34. Cool. So that's our scope. If we try to go y equals 77, that should work. I'm going to have to find a faster way to do this instead of all these individual commands. That's not correct because the scope should be able to set y to 77. And it's also finding y, right? Where's our assembly? Scope start, declare scope end. Did I forget to run this? Yeah, okay, now we have assignment and declare. Right, in our scope. I think I just forgot to actually compile our code. 77, okay. Yeah, because we declared it here, we reassigned it, then we reassigned it again in the scope, which is totally fine. And then we assign Z to Y when we declare it, so 77. If I try to do this, that should be an error. Identifier array exists. And if I try to do this, that should also be an error. Undeclared identifier. Okay. I think that's pretty good. I feel like I fumbled a little bit during this one. Still learning. Still learning to try and verbalize things in a way that makes sense. I hope I didn't kind of ramble on and make things confusing during this one. But I'm pretty happy with that. I'm pretty happy we got those 2 changes in, right? Now we have a different syntax for declaration assignment, I'll call it, versus just straight up assigning to an existing variable. And we added scopes. And it all seems to be working nicely. So next time we're going to do some quality of life stuff, I think. Make our code more understandable and more robust and better error messages. Because right now they are just trash. They're trash. Yeah. I think that's a worthy goal. At some point we should get arithmetic going too. That seems fairly important to actually be able to do work. Great. Okay. I think that's enough rambling from me. Thanks for stopping by. Give the video a like if you're enjoying the series and if you want me to keep going. Yeah. Not very good at these sign-offs yet. Okay. Ciao.